Hello you guys, welcome back to my channel. So now in this video we're going to be starting off with our very new chapter, which is about the decision control structure. Okay, this is considered as one of the most important and useful topics in the C language. So before we really waste our time, let's just dig it in, okay? We all need to alter our actions in the face of changing circumstances. That's something really true. We have to, under different circumstances, you have to take different types of decisions. So, if the weather is fine, then I'll go for a game. This is an example, okay? If the highway is busy, I would take a diversion. If she says no, I would look elsewhere. You can notice that all these decisions depends on the condition being met. So similarly, C language too must be able to perform different set of actions depending on the circumstances, okay? So there must be different circumstances, different conditions that can come across your real life, and on the basis of those circumstances you take different kinds of decisions. So the same goes with the C language, right? So in the C language, if you have some certain conditions, then you can perform different action, and if you don't have those conditions, then you can perform other kind of actions. So it's all gonna make sense once we write our first C program that contains the decision control structure. Okay, so C has three major decision making instructions, known as the if statement, the if else statement, and the switch statement. So these are the three decision control structures in C language, okay? So a fourth, somewhat less important structure is the one that uses conditional options. So in this chapter, we will explore all these ways except switch, which has a separate chapter devoted to it later, in which a C program can react to changing. Okay, so we're going to be studying switch chapter. That's a whole different chapter that we're going to be studying later on, but it still comes under the topic of the decision control structure. Okay, so in this video, we're going to be or in this chapter, we're going to be looking forward for the if statement and the if else, okay? So, okay, decisions. As mentioned earlier, decision control instructions can be implemented in the C using the if statement, the if else statement, the conditional operators. I'm going to be telling you guys all of these step by step, okay? The else if statement, multiple if statement, and the switch statement. Remember that we're going to be studying the switch statement later on in the next chapter or maybe afterwards, okay? So, okay. Now the if statement. First, we have to get through the if statement. Okay, if statement is used to execute statement or list of statement if it meets certain conditions. Okay, if there is a certain condition in your C program and if that condition becomes true, then the statement after the if is going to be executed. If the condition doesn't met as required by the if statement, so if the condition doesn't met, it means false. So the program beneath the if statement or between the two curly brackets afterwards the if statement is not going to get executed. So this is the concept of the if statement. If the condition is true, it's going to be executed. If the condition is false, it's not going to be executed. Or you can say run, okay? So like most languages, C uses the keyword if to implement the decision control instruction. The general form of if statement looks like this. Okay, so for every, you can say functions in the C language, there is a specific syntax, okay? So for the if statement, we have this syntax. The if, you're going to put a condition between two parentheses, and then after the setting up the condition, you're going to put two curly brackets again, and then between those two curly brackets, you're going to write your statement that you want to get let it be executed after the condition is true. Okay, so condition always returns either true or false. You should keep this in your mind, that your condition can either be true or it can either be false, right? So if it's true, this portion will be executed. If it's false, it's not going to be executed, and the compiler will go after whatever is after the if statement, whatever is after these two curly brackets. Okay, so it's going to ignore that, and then it's going to move forward. But if it's true, obviously it's going to run this portion and then move to the next statement, whatever it is. So how if statement works. Now this is really conceptual, and you should not ignore that. Okay, so if condition returns true, then if block will be executed. That's something I have explained it to you guys right now. If the condition is true, if the condition is met, then this portion will be executed. If condition returns false, the control will be sent to the next statement of if block. If the condition is not true, then the compiler will ignore this portion right over here, and then it's gonna just you can say jump forward to whatever this next statement is after these two curly brackets. Okay, so then we have some relational operators. So operators, this expression, these are different operators. Okay, so these are really important operators that can be used in your C program while solving different kind of problems. So we have this double equal operator. So x is equal to y. If you have any value x, for example, let x be equal to 2, and then you have a value of y which is equal to 3, let's suppose. Okay, so is 2 equal to 3? No, it's not equal to 3. 2, and then if I change the value of y to 2 and just you can say vary it to 2, so is 2 equal to 2? Yes, 2 is equal to 2, so the condition is true. Okay, let me just we're gonna be looking through an example. Okay, I can just explain it to you guys right over here. Okay, for example, you have 2, right? 2 double equal to 2. Yes, this is how it works. Okay, this is false, right? 2 is not equal to 3. I hope this makes sense to you guys. Okay, so now moving on to the next. This is this is another expression, or you can say relational operator. So this is like not equal to. This symbol is like not and then equal to y. Okay, now this is how it works. Like 2 is not equal to 3. Yes, that's true. 2 is not equal to 3. Is 2 is not equal to 2. That's false. Okay, this is how it works. We're going to be using these relational operators in our further programs, then it's going to make more sense to you guys. Okay, so then we have another relational operator that is less than, greater than. I know that you guys have already studied about it, but let's just take an example as well. 2 is less than 3. That's true. 2 is greater than 1. That's true, right? And this is less than equal to. Okay, 2 is less than equal to 2. Yes. If 2 is not less than, 2 is not less than 2, but 2 is equal to 2. Okay, the compiler is going to ignore this part. Okay, because these are the two relational operators we're using at the same time. So if either one of it becomes true, then the whole statement will become true. Okay, then the same goes here, less than equal to 2. Okay, so I hope this table makes sense because we're going to be using these relational operators later on. Okay, now let's take an example right over here. Okay, yes, we have an example here. Okay, this is the program, and I'm going to copy this program to save some time, and I'm going to just paste it here. Okay, and then I'm going to mention some of the libraries. Hashtag include stdio.h, and then we have another one, hashtag include conio.h. Okay, so this is our program, and then let me show you how this program is working. Okay, so as you guys know about, these are the libraries. This is the main function, and then between these curly brackets, these two curly brackets, we have our program in, and inside this program we have declared, or you can say marked or saved some memory location in our RAM by the name of marks, and then we have assigned the value 80 to uh, to the marks location, okay, in your RAM. And the clear screen is just to clear your output screen. If you want to apply it, that's okay. If you don't, so that's totally fine. I'm not going to do that, okay? So then we have a condition. If marks and, okay, this is something, okay, greater than equal to. That's, we're going to be needing some changes. Marks is greater than equal to 50. Okay, if marks is greater than equal to 50, hold on a second. Okay, so if marks, if is a condition, and whatever is the condition, you're gonna write that condition between these two parentheses. Okay, so if marks is greater than equal to 50, then you're pass. Okay, and then if marks is not greater than equal to 50, or you can say it's less than 50, then you're fail. So your marks is 80. So the compiler is going to rate that, okay, marks equal to 80. It's going to save that, and then it's going to move on to the next statement, this one, and it's going to check the condition. Is the condition true? Marks, what's the value of the marks? 80. 80 greater than equal to 50? Yes, 80 is greater than 50. So it's going to run whatever is between these two curly brackets. This is printf pass. And okay, now the compiler is going to go further and check another condition. Marks is less than equal to 50. What's the value of marks? That's 80. So 80 is not less than 50. So compiler will ignore this portion, and it's just going to move on to the next statement, which is the get ch. Okay, so now we're going to be running this program, and let's see the output. Okay, you are pass. Okay, so the output is pass, and I've told you guys how this is working, this whole program. Now it's just waiting for me to press enter so that this can be vanished. Here you go. Okay, so this is how it works. If the condition is true, it's gonna run the statement, whatever is between the curly brackets after the if statement, and if the condition is false, like this case, then it's not gonna it's gonna just ignore this part and just move on to the next statement. So this is how if works.